Let's next tackle solving a system of linear equations again using the elimination method. And the system that we have is 3y being equal to 8 plus 4x and 6x equal to 9 minus 2y. And you recall that the first step in using the elimination method is to put both equations in standard form. So let's do that next. The first equation will become 4x minus 3y equal to negative 8. And the second equation becomes 6x plus 2y is equal to 9. Now in this case, I think it might be easiest to eliminate the y terms because the coefficient of one of the y terms is negative and the other is positive. So let's multiply the first equation by 2 and the second equation by 3. So that will produce for us then, in the first equation, 8x minus 6y is equal to negative 16. And the second equation becomes 18x plus 6y is equal to 27. Now if we add the two equations together, we'll end up then with 26x is equal to 11. Our x then is equal to 11 all over 26. Now to find y, I think what I'm going to do is go back and use the first original equation, and we'll then have this that will say that 3y is equal to 8 plus 4 times the quantity 11, 26. And continuing then 3y is equal to 8 plus 44 over 26. 3y is equal to, now we'll get a common denominator here, so expressing 8 as a fraction over 26 becomes 208 over 26 plus 44 over 26. So next we have then 3y is equal to 252 all over 26. And we can reduce that to 126 all over 13. And then to finish up, what we'll do is multiply each side by 1/3. So we have y is equal to 1/3 times 126 all over 13. And we can do a little reducing here. So 3 will divide into 26, 126, 42 times. So then y will turn out to be equal to then 42 all over 13. So we can then say that the solution as an ordered pair to this system is the ordered pair 11 all over 26, comma, 42 all over 13. Certainly not very nice numbers, are they? Now for practice, let's check the solution we just came up with, which was 11, 26, 42 over 13, into one of the equations. And I'm going to choose to use the second equation here, which is the 6x equals 9 minus 2y. So you can see that what I've done down below here is to replace the x with 11 over 26, which is right here, and the y with 42 all over 13. So if we multiply on the left-hand side, we'll end up then with 66 all over 26. Right-hand side we have 9 minus then 84 all over 13. Now when we reduce here on the left-hand side, the 66 over 26 will reduce to 33 all over 13. And if we change the 9 to a fraction over 13, that becomes 117 then, all over 13. Then we have then minus 84 all over 13. So 33 over 13 on the left then. And then 117 minus 84 does produce then 33 all over 13. So our solution checks in the second equation. And as always, let me encourage you to check the solution in the first equation.